I need to be able to lab stuff up before I put it in production. Well, now you can create a separate VDC on your 7K to kind of create a test network and say, I want to dedicate these interfaces to my test network. And maybe I can, allow the less senior engineers in my company to log into that VDC and make changes because I know it's not going to affect my production environment that my business is running on. And that's all done with role-based access control, which is another addition that Cisco brings with the NXOS operating system, right? I mean, previously, if any of you are familiar with iOS, which is the old operating system, you had the concept of privilege levels. So you had a user that was assigned privilege level 15, which was like the administrator, the root user, that could do basically everything on the device. Well, now you don't really have those privilege levels anymore. You have roles, and those roles have rights to different features, and the roles are applied to users. So you can say this user only has access to these features, or this user only has access to this VDC, or, and then you can get very, very granular with it, as opposed to just saying, hey, either they have no access or they have all access. You can kind of like pin that down more often, and more granularly, and it gives you that capability. We also have something called Cisco TrustSec, which is based on, I believe, the RFC is 802.1AE or 3.8, 1.8, 1.8. Yeah, it's a physical spec, so it's 1.8. 802.1A, it's LinkSec or MACsec security. The Cisco product marketing wizards call it Cisco TrustSec, but it's 802.1A, which is LinkSec or MACsec, and it's basically link level security. So before, you were worried about things like man-in-the-middle attacks, where somebody could run a program and send out a gratuitous ARP and redirect your traffic to their workstation and, open up a Wireshark and look and see what you're doing and sniff your passwords as they went across the wire. Well, now with, CTS, Cisco TrustSec, you're actually running encryption between your network devices or between your links. So you can say, at a wire level, I want to be able to encrypt my traffic physically on the wire, before, and not have anything in the middle know any different. So basically, there's a hardware chip on the line card in the switch that actually does the decryption at the front of the line card before the switch can even process it, basically. So all your traffic is encrypted in flight. So your kind of your sniffer attacks, man-in-the-middle attacks, and things like that kind of go out the window at that point because they open up a Wireshark and all they see is encrypted traffic. So that's kind of cool. OTV, overlay transport virtualization, is another cool feature that Cisco's doing on the 7K. Y'all hear a lot about, when you learn about networking, you hear a lot about spanning tree and keeping spanning tree isolated so you can keep your fault domain separate so you don't have broadcast storms, that sort of thing. Well, now with high availability, and VMware and stuff coming into the environment, people say, well, I want to have active data centers, right? I just did a design for a customer where they have one data center over in Warren, Michigan, and another data center in Milford, Michigan. And they have dark fiber between the two. And they say, well, now, instead of just having our backups live in Milford and have Warren be our production data center, we want to be able to fail between them at will and say, if Warren disappears off the face of the earth, there's an earthquake or whatever, we want to be able to just have Milford be already up and running and have it, nobody knows.
Hot site. Right,
exactly. So active data center scenario. And part of the way that that's accomplished while still maintaining your spanning tree isolation is with this technology called OTV, where you can actually, instead of extending your layer 2 domain in your broadcast domain and your spanning tree domain out across data centers to give that layer 2 connectivity for clusters and things like that, you can actually take that layer 2 traffic now and encapsulate it in a special packet with an OTV encapsulation and route that layer 2 traffic across your WAN. So it'll get decapsulated on the other end, and then the other side will see it as normal layer 2 traffic and switch it over. So now you have layer 2 connectivity without really having layer 2 connectivity. And the advantage that gives you is you can do things like vMotion across data centers. So you can have a vSphere cluster, half of the nodes live in this data center, half of the nodes live in this data center. Hey, if this data center is too busy, I'm going to dynamically move all my servers over to this side and nobody's going to notice. Or if I have, Microsoft clustering services or whatever you want to use for your clustering solution, I want to have half of my nodes live in this data center, half of my nodes live in this data center, and I'm going to advertise my IP space out of both. So when users hit my data center, they don't really physically know which one they're hitting. They just know that they're hitting the cluster. And how the cluster routes that traffic between nodes is up to the cluster, but half your nodes can live on one side and half your nodes can live on the other side. So if I have my one data center disappear, well, who cares? I still have half my cluster up. And that can be entirely transparent to your users. So there's a lot of problems that are solved with technologies like OTV that are just now, there were ways to do it before, but you had to extend your layer 2 domain, and you had to kind of put yourself at risk by doing that with broadcast storms and with fault isolation and things like that. So now you don't really have to put yourself at risk anymore. You can layer 3 route your layer 2 traffic across the LAN cloud, and it allows you to do things like extend your domain for VMware and clustering solutions and things like that. So that's really cool. And then on the 5K right now, the other cool thing that we have going on is FCOE, which is Fiber Channel over Ethernet, was recently ratified as a standard, right? So now you have servers and they're connected to the storage arrays by a technology called Fiber Channel, which is usually a separate host bus adapter that goes in the server, and you have a Fiber Channel connection out to a separate SAN network. Well, now all that stuff is kind of convergent. And the advantage that you get from that is now you can put these, what Cisco has called a CNA card, or Converged Network Adapter, inside of your server and run your Ethernet traffic and your storage traffic across the same 10 gig infrastructure, 10 gig Ethernet infrastructure. And it's all, even your storage traffic is encapsulated over Ethernet. So now you no longer have the separate infrastructure for storage. You don't have to pay people to manage that. You don't have all that cabling under your floor. You don't have the cooling problems. You don't have all the stuff that comes along with maintaining a separate infrastructure. And you can extend that straight to your server. So now instead of having all these separate redundant paths for Ethernet and separate redundant paths for SAN and B fabrics, you can do it all over 2 redundant connections to your server, and you don't worry about whether it's storage or whether it's Ethernet or whatever, because you manage it all from the same infrastructure. So that has huge cost implications for many businesses, right? I was walking through a customer's data center recently, and I grab one of the little suction cup things, and I pull up a 4 tile, and I'm trying to figure out where we're going to run this fiber and install this switch. And the entire raceway for the cable, for all the cables is full, entirely full under the floor. There's no room for anything underneath here. So, I pull up this 4 tile, and I'm like, they should probably do some fiber channel over Ethernet, because I see a lot of fiber that probably doesn't really need to be here. So you can reclaim a lot of that physical infrastructure too, right? And a lot of companies, they don't run that cable themselves, so they may pay a contractor to do it. So if you're paying a contractor every time you run a cable, things like FCOE become a very big deal, because you can save a lot of money that way. So that's really cool. And finally, the last thing I kind of really had on my agenda was just one of the other cool technologies that the Nexus OS operating system brings into the mix, which is VPC, which is Virtual Port Channel. So I don't know how many network people there are here, but this is kind of a cool trick with people that are used to dealing with spanning tree and block boards and things like that. So say you have a switch, right? I don't care, it could be any sort of switch, I don't know, 3750 or something. And then you have, a pair of core switches. You can say, these are my switches that run everything inside my data center. So we have a Nexus 7000 there, another 7000 here. And say you have, I don't know, you normally wouldn't connect switches to this exact model, but say you have client workstations or something, or servers, but say you have client workstations directly connected to the switch. In order for, to provide redundancy or link level redundancy, you don't want part of your network to bring down all of these users if you lose one link going one way or the other. So everybody, what they traditionally do is create 2 links there. Well, the problem with that though is the way that switches forward traffic is when you send a broadcast out, which broadcasts are done at layer 2 for various things, a lot of different applications actually within the broadcast. But the problem with that is when you connect all this stuff together, you create an infinite loop, right? So you send a broadcast out, and what a switch does when it receives a broadcast frame is it floods it out every port except for the one that it receives it out. So you get a broadcast from a workstation, send it up, so this guy receives it. This guy floods it out, his connection to the other switch, who floods it out, his connection down here, and now we have a broadcast storm because we have a loop in our physical topology. Well, you're gonna say, why do I care? Well, first of all, it needs a bandwidth because you have this traffic hitting every link in your infrastructure.